In this video, we're going to talk about the different values of the quantum number L, and this is the quantum number that tells you the type of orbital it's going to be in, S, P, or D, or F. And then the sort of the magnetic quantum number, which tells you what position in the orbital that the electron will be placed in. So the principal quantum number is N, that is going to be 3. Remember our 4 quantum numbers? We have the principal quantum number, which is the row in the periodic table. We have the quantum number that determines the type of orbital. We have so this is the angular momentum quantum number. This is the quantum number that is the orientation quantum number, where in the orbital the electron would reside. And then finally, the easiest one is the 4th quantum number, which is the spin quantum number. Is it going to be spin up or spin down? Plus 1/2, minus 1/2. This quantum number is easy because it's either the electron will go spin up or spin down. This quantum number, the first one, is easy because you just look at the row the periodic table is in. So here we're looking at the 3rd row of the periodic table. These two take a little bit of caution. So let's go ahead and look at problem 756. So it's saying n equals 3. So if you have n equals 3, you're basically looking at the orbitals 3s, you're looking at the orbitals 3d, and then you're looking at the orbital 3p. Right? So the s orbital, okay, and this is the 3rd row of the periodic table. Okay, that's the principal quantum number. So basically, getting the periodic table out, you're looking at, if this is n equals 1, n equals 2, this would be n equals 3. Okay? Now, n equals 3, you have 3s, and then it goes all the way to 3p. Don't forget now, the d orbital actually has the 3d. So this is the 3d orbital. These are the 3s orbitals, and electrons here take the 3p shape. So it's going to be 3s, 3p, and then the transition metals start right here, and they start with 3d. Coming back to the problem, the s orbital actually can house 2 electrons. The d orbital can house 10 electrons, 1, 2, 3, 4, 5. Each one goes spin up and spin down. And then the 3p orbital can house 6 electrons, each one going spin up and spin down. So these are how the electrons go marching. In an s orbital, whether it's 1s, 2s, 3s, or 4s, they're going to pair up, spin down. Let's go to the 3p orbital. Okay, when the electrons start marching, they're going to march up, spin up, spin up, spin up, and then spin down, spin down, spin down. And with the d orbital, they're going to go spin up, spin up, spin up, spin up, spin up. And then they have no place to go. Instead of going to a higher energy level, they will actually go spin down and pair up. Spin down, spin down, spin down. Spin down and spin down. So we already know what n is. That's going to be 3 because this is a 3s orbital, 3d orbital, and 3p orbital. Okay, the 3d, once again, just to remind ourselves, are the transition metals. So this would be the 3d block. This would be the 4d block, and then 5d block, so on and so forth. Well, you're going to have to memorize a key here in order to get the L. So the second quantum number L depends on what orbital the electron is housed in. If you're in an s orbital, the L is going to be 0. Okay, so the L equals 0 signifies an s orbital. This is just something you're going to have to memorize. Let's skip over to p. If your L is 1, this represents a p orbital. And then finally, if your L is 2, this represents a d orbital. So if you're talking about an s orbital, you're talking about an L of 0. The emps of L, that 3rd quantum number, is the place in the orbital, the orientation that the electron will go into. So it's easy for an s orbital because there's only one place. Okay, all of these orbitals have a shape, and there's only one shape for the s orbital, and that's a sphere. So for an s orbital, no matter what, your emps of L is going to be 0. Now for a p orbital, let's skip to the p orbital here. Okay, we got to memorize that L, our second quantum number, is going to be 1. But you see the p orbital takes the shape of dumbbells. So you have a dumbbell along the x-axis, you have a dumbbell along the y-axis, and you have a dumbbell along the z-axis. So these orbitals have a very specific shape. Okay, so we have a dumbbell along x, we have a dumbbell along y, and then we have a dumbbell that's sort of pointing above and below the plane of the piece of paper. Okay, so these points here where there's 0 electron density, that's called a node. So the m sub L, that third quantum number here, can take on 3 values. We always put the middle one, okay, this is m sub L we're talking about here. We're always going to put the middle one at 0, and then we're going to go sequentially. So this sequentially will be +1, and then to the left would be -1. So for p orbital, L is equal to 1, that's our key. M sub L can either take on -1, M sub L can take on 0, or M sub L can take on +1, okay? And that's shown here. Here we have an electron, just pointing here, highlighting it in gray. An electron that is in the -1 third quantum number. An electron that's in the -1 third quantum number, that's spin up. That is the address, that is the location of that electron. Now going to a d orbital, okay, so n will always be 3. L here is going to be 2. Okay, this is just something like a key, like a code you're just going to have to know. Now the d orbital is a little bit more complicated in its shape. Okay, well the p orbital is dumbbells across all 3 coordinate axes, x, y, and z, and the s is just a plain old sphere. The shapes of the d orbitals are far more complicated, and I'm not going to draw them or depict them in this video, in this very short video, but they have different shapes and geometries and orientations. But the m sub L, the orientation orbital, where these electrons are going to go, the middle one, as always, is going to be 0, and then we're going to go sequentially. +1, +2, this is the d orbital now, which holds 5 slots for 10 electrons, spin up and spin down, and then -1, -2. So for the d orbital, the angular momentum quantum number, the second quantum number, is always going to be 2, but your m sub L can take on anywhere from -2, spin up, spin down, -2, spin up, spin down, -1, it can be spin up or spin down, 0, spin up or spin down, it can be +1, spin up or spin down, or it could be +2, spin up or spin down. So